like depth like how I need, and I just don't understand how I'm supposed to calculate where a barnacle is gonna move on a wheel. It's like I don't understand what I'm doing.
Okay, okay. Now, do you remember a recent conversation that you and I had about the unit circle?
Um, no.
Okay, you asked me a question that looks so much like this circle
Mhm.
and this point moving around the circle, and how at any point a triangle can be made that describes the distance from the origin along the x-axis and along the y-axis.
Yes.
You remember that conversation now?
Yes.
Okay, okay. I promise you that conversation is important in this conversation. Does that make sense?
Yes.
Because when you described the problem, modeling a water wheel, in my mind, my experience mind, I said, oh yeah, the unit circle is about the only thing I can see that would help somebody else see what that looks like.
Mm.
A barnacle stuck to a water wheel that's moving around the wheel.
Yes.
Trust me, in the 34 years since I took calculus, I've never been given a reason to care about a barnacle moving around a water wheel. I haven't even seen a water wheel.
Yeah.
All right, so this may not pertain to the lives that we live, but it is modeling something that we at least need to and see and visualize to solve the problems set before us. Yeah, so yeah,
Mhm.
that's enough of a reason for me. Does that work for you?
Yeah.
All right, so let's engage it so that we can learn from it what we can learn from it. All right, so having said all of that, all right, at time zero, yeah, it hasn't moved at all,
Mhm.
and yeah, and I'm taking distance to mean the. Can you see my mouse?
Uh. Yes.
Okay, so I'm taking distance to mean if I go from this point to this point, my barnacle has moved some number of meters.
Mhm.
Is that fair? And what I'm doing here now is I'm trying to understand this scenario without starting at the beginning. And now,
Mhm.
and now the trust I want to have with you here is you've seen it from the beginning. So if I say something in my assumptions and trying to piece together what's going on that's not quite what you saw, then you tell me. No, it wasn't quite like that, but what it looks like is this barnacle is going to start at a certain point and move around this orange wheel, and we're going to be analyzing how far it has moved at certain points in time as this water wheel spins.
Mhm.
Now, can you visualize that it is spinning and it is spinning around this axis defined by the origin?
Yes.
All right. Do you accept that that looks like a clock ticking?
Yes.
All right. Is that something you can easily visualize?
Mhm.
Okay. So that's what I'm using in my head too. This is just like the clock ticking, the second hand moving around the clock, and 60 seconds later it's going to end up back at 12. That helps me, believe it or not. That helps me see what's going on, to have something concrete that I can compare it to, given that the example they're showing me is not really something I'm feeling. I don't have any connection to a water wheel. I,
Mhm.
I have less of a connection to a clock, but at least I have seen a clock. I've seen a clock today. All right, so at time zero, you have not moved at all,
Mhm.
and you are at, yeah. So what do you think height is now? Because I'm not sure. What do you think height is?
Um. Uh.
Or let's come up with a reasonable guess of what height is.
Maybe if like we were to draw like a triangle, then it would be the y, or maybe the highest point that it reached. I don't know.
Well, but based on what I'm seeing now, I'm guessing that the height is the distance you are above or even below the water level.
Mhm.
See what my mouse is doing there? I'm guessing that that is the height. So when we get to about right here, you are this far above the water level, and I'm saying that's what D is. That's what D is going to be, the distance
Mhm.
above water level. And then A is probably the distance along the x-axis. Yeah,
Mhm.
that's probably what's going on here. That's probably what's going on here. All right, so at time pi over 2. Now here's where the unit circle becomes important. Pi over 2 is expressed in radians. Now, how many degrees is pi over 2 radians?
90.
90. All right, so pi over 2 is talking about this green dot. I think that is the green dot.
Mhm.
And is that somebody coming to our meeting? Yeah, that's Jack.
Mm.
All right, so give me just a second.
Yeah.
Hey, is that Jack? Good morning, Jack. Hey, Jack. How you doing, man? All right, let's move forward. Jack will catch up. All right, where was I? Yeah, at the green dot that I'm pointing at, that is pi over 2 radians or 90 degrees.
Mhm.
No, you know what? That's not where 90 degrees is. The green dot is times 0. That is 0. And on the unit circle,
Oh.
that is 0 degrees. So once we start going clockwise from that green point, I think that is at 90 degrees. You have
Mhm.
rotated through 90 degrees. You have rotated through 1/4 of the unit circle at this point.
Mhm.
And as we trace on around here, then you have traced through pi radians or 180 degrees at this point.
Mhm.
Let's keep going. And by the time you get here, that's 270 degrees or 3 pi over 2 radians. And then when we get back to the green point, that's 2 pi radians or 360 degrees. That's going all around the unit circle. Hey,
Mhm.
Jack, how you doing, man?
Doing good. How are you?
All right, all right. We're talking modeling the water wheel here. Is this a lesson you've already passed? I think you have. Does it look familiar?
Sorry, what did you say?
Does what I'm showing on the screen here look familiar to you? Is this a lesson you've already completed?
Oh yeah.
Yeah,
Yes, sir.
think you have. Think you have. All right, so yeah, we're walking Heaven through it here. So Heaven, you with me so far?
Mhm.
All right, so let's talk about what I'm seeing here. At all right, so this one's finished, and you got to do this one now. Is that what we're looking at?
Mhm.
All right, so you know that A, B, and C are distances of 1/2, 1, 3/2, and then the heights. All right. All right, Heaven, we might need to back up to, yeah, I'm not sure any of these frames will give me video, but let me look at these. Yeah, this might be what we need to do. All right, maximum height reached by the barnacle is 1 meter. Minimum height is -1. It'll travel 2 pi meters in 1 revolution. All right, that's fair. Boat is traveling at 1 meter per second. Alright, so yeah, it would take 2 pi seconds to get back to the beginning. That's fair. Okay, so Heaven.
Mhm.
Alright. The maximum height above sea level is going to be 1.
Mhm.
And it's at that point where is at the point the cursor is touching now.
Mhm.
The minimum height is going to be -1, as shown
Mhm.
by the cursor. So it's going to hit the maximum height at 3 pi over 2 radians. See, if you start
Mhm.
here and trace around, it's going to hit the minimum height at pi over 2 radians. It'll return to a water level of 0 at pi radians. It'll hit the maximum height at 3 pi over 2 radians. Then it comes back to the minimum height at 2 pi radians. See that?
Mhm.
All right. And that's how you see at time 0, you're at a height of 0. You are 0 meters above sea level at time 0, and you return to that point at time 2 pi.
Mhm.
All right, so at pi over 2 radians, do you see that the height is -1?
Yes.
All right, and that's point D. Point D is a height of -1. Now at pi over 2 radians, what do you see? What should E be?
0.
Yeah, E is a height of 0. And then at 3 pi over 2 radians, what should point F be?
Um. 1.
Right, right.
Oh, okay.
Now that's what's going on there. Now debrief with me. What made that hard to see? Because I struggled through that one. What made it hard to see?
Um. To be honest, I don't know. I just saw a bunch of letters and numbers, and I just didn't understand.
Okay.
And yeah.
Now I'm going to say the same thing in a slightly different way, since I'm a gray head. When I'm presented with a situation, and that situation has terminology variables, those terminologies and variables are my first hurdle. I've got to know what they are presenting and how they are presenting it to me, and I've got to know what all these things mean. So when I see that table, I've got to look at that table and say, okay, you're showing me a distance of what? Well, it turns out that it is the distance traveled by this green dot as it traverses or moves around this circle. This circle has a radius of 1 meter. Now that now tells me I treat this like it's a unit circle, because that's what the unit circle is. Circle of radius 1 that we can use to describe motion using the coordinate axes and points on this circle. Okay, now I'm getting somewhere. I know what this distance means in this diagram. So what is this height? Okay, the height is the distance above or below the water level. That's what the height is. Now I know what each of these items are in this table. I can see time, which is measured in seconds, presented to me in radian measures. And that further supports the notion, oh, okay, I'm dealing with a unit circle here. Unit circle. So time 0 seconds is at this point. Time pi over 2 seconds is down here. Time pi seconds is right there. And then time 3 pi over 2 seconds is right here. Okay, now I think I see what I'm dealing with.
Yeah.
Now these distances, if I know that starting here and going all the way around takes me through 2 pi radians, then that tells me each of these stopping points would represent 1/4 or 1/4 of my journey. I've gone 1/4 of the journey here. I've gone 1/4 plus 1/4 here, which is 1/2. I've gone 1/4 plus 1/4 plus 1/4, which is 3/4 here. And then when I reach this point, I have gone through a complete revolution. I've gone all the way around once. I've completed one full revolution. And in one full revolution, I go 2 pi radians. So at each of these 1/4 points, I'm going 1/4 of the way. And what this is really saying down here is A is 1/2 pi. Because see, if I'm traveling 2 pi, going all the way around, when I've gone 1/4 of the way, I've gone 2 pi divided by 4, or 1/2 pi, which can also be said pi over 2. See that? But it's important to note that this is 1/2 times pi. That's what this represents. But if you don't know that, you might not even see pi down there. This is 1/2 pi. A is 1/2 pi. B is pi, or 1 pi. C, which is this point, is 3/2 pi. 3 pi over 2.
Okay.
Is that working for you now? Does it sound good when I say it?
Yes, thank you.
All right.
That made it easier.
All right.
And then it's just one more on frame 8. I got one part of it wrong. I started understanding like kind of more on this problem, but the one that I got, I just want to know why it's wrong.
Okay, so look at number 8. All right. Give me a second to digest this scenario.
Okay.
Riding a bicycle on a 6-foot wall. Who does that? I don't. At a rate of 1 foot per second. The wheels have a radius of 1 foot. Piece of gum becomes stuck to the rear wheel and continues to travel with the bicycle. Okay. You're riding a bicycle on a 6-foot wall. I'm going to give you that. I don't know why you do that, but that's what you're doing. You're riding at a rate of 1 foot per second. I would rather walk. That doesn't sound like you're going that fast. But I'll give you that too. Wheels have a radius of 1 foot. Piece of gum becomes stuck to the rear wheel. Continues to travel with the bicycle. So as my bicycle continues to move at 1 foot per second, that piece of gum is going to move here. Then it's going here. Then it's going here. Then it's going here. Do you see all that? All right. So the questions. What is the gum's minimum height? Well, for reasons I'll never try to explain, we are riding this bicycle on a 6-foot wall. So we start 6 feet above the ground. So the minimum height is 6 feet. Now, the maximum height, trick question. Trick question. I'm clearing my throat for real now, but trick question. All right. The distance from the cursor to the green dot is 1 foot, right?
Yeah.
Which defines the radius of this wheel. So visualize with me now. Watch the green dot travel to right here. Now it is at this point 7 feet above the ground. Do you see that?
Oh, yeah.
All right. Now follow around to this point.
Oh.
Now how far above the ground are you?
8 feet.
8 feet. Now trust me, Heaven. If the Edgenuity folks were thorough, they would animate this and they would let you see this point travel to this point and to this point so that you can visualize, oh, yeah, you know what? It is now 6 feet plus 2 feet above the ground when it gets to that point. Now, perhaps the subscription level we paid for doesn't include video animation. But that one would have made this a little better. Now, forgive me for the commentary. You could make this even more straightforward without this scenario. I'm riding a bicycle on a 6-foot wall at a rate of 1 foot per second. Because what most people would say there is, why?
Yeah.
Why? Well, because that's what I'm doing. Okay, well, to each his own. It makes it a little more difficult for me to see what you're saying, though, when I have to work and wrap my mind around things that kind of don't make sense to me.
Yeah, it's like the examples that they give me is just like how would I apply this to real life, or like why would I need to know that? And that's what like gets to me really, is like, what?
Well, here's where I admit to you that and you, Jack, that everything about math is not designed for you to be able to apply it to much besides the next test.
Yeah.
Now the good news is, after you see enough of these scenarios, you're bound to come across one that relates to you, or you'll have some insight and a sensitivity to design some that do relate to you and people like you. And that's the beauty of having all kinds of different teachers from all walks of life, is if everybody creates ideas that are kind of relevant to the life that they live and we all share them with each other, we probably all grow a little bit in that process. That makes sense?
Yeah.
Yeah, I hope it does. There I go again, making sense even with stuff that doesn't really make sense. It's a bad habit I have. Bad habit. All right, so now you got this one right now, but you see why, right?
Yes.
If this wheel has a radius of 1 foot, that allows us to visualize the path that this circle, that this point, this piece of gum will travel as one trip around the unit circle, where you cover 2 pi radians. All the way around the unit circle is 2 pi radians.
Yeah. Okay. Thank you.
Yeah, and in this example, now everything is measured in feet, so we have traveled 2 pi feet.
Mm-hmm. Okay.
Jack, you tracking all this, my man? I'm sure you are.
Yes, sir.
All right. I ain't say nothing crazy, did I?
No.
All right. Keep me straight. All right. And I didn't mean to hold y'all this time, now, Jack. Now, all I want you to do is check in and let me know how you're doing. And when you have questions like Heaven had today, then we sit here and we work through it and make sure we're all moving and grooving. So, did you see your progress report posted in Aspen this morning?
Me?
Yeah.
Yes, sir. I think I'm at 60% or a little bit ahead. Do I need to go all the way?
Oh, what do you mean go all the way now?
Cause like I was thinking, because of Corona, you could like stop at a certain percent, or do you need to do 100% still?
I'm pretty sure we're back to 100%. I got you now. I'm pretty sure we're doing 100% now.
Okay.
Yeah, since we at least started the semester under some normal crazy circumstances.
Yeah.
Yeah, back in the spring now we had to stop under some crazy circumstances, and those were some adjustments that they made for the spring. But now I think the adjustment this semester is, for the most part, all the finals have been done away with. Are you aware of that?
Oh, I didn't know that.
Yeah, it was tricky. I remember being told that in the part A of classes, there is no final, but in the part B, that there would be finals. And I think somebody realized that is difficult to understand because you got a lot of folks at PLC who are doing part B of a class here in the fall semester.
Mm-hmm.
So I think they've gone back and now said, at least for us, we're not giving anybody any finals. Now, I have had some students take the finals just to kind of prove something to themselves, but they won't be part of your final grade.
Oh.
So unless you're just into proving things to yourself, now you probably okay not taking them. But yeah, I would never deny a student the right to take it, because if you want to take it to see what you got, then you might as well, since it's there. All right, so is that clear as mud now? Is at least about finishing the classes, work them all to whatever percentage is left without the final. It'll probably be like 97%, something like that.
Yes, sir.
Yeah, but I'll be watching that too now. But once you hit the final, you'll be done. All right. Anybody got anything else?
No, that was all.
All right.
Thank you.
Look, we almost went bell to bell today, y'all. We worked today.
Yeah.
That's all right. Well, yeah, appreciate you. And good to see you, Jack. Check in with me, man, as much as you can. All right. Y'all take care.
You
All right,
too.
you
Have
too.
a good day.
All right.